Hello everyone, this is Shankho Shubhra Rai Karmakar and welcome to my channel, that is Refraction Guidelines. So this is the third video on optics, and today we will discuss on the topics of total internal reflection and the refraction through a prism. So here we go. As we have told earlier, the light ray may propagate through any transparent medium, but we may observe an apparent bending if the light ray propagates from optically rarer to optically denser or optically denser to optically rarer. And we know earlier that the light ray will move towards the normal if the light ray propagates from optically rarer to optically denser medium, and will bend away from normal if it propagates from optically denser to optically rarer. But there will be no deviation of light ray if the angle of incidence becomes 0 degree. Now we will observe several angle of incidence from denser to rarer medium. In the first example, the angle of incidence of the light ray is 0 degree. That means it is passing through the normal, so there will be no deviation of the light ray and it will propagate through a straight line. But for the next case, there is an angle of incidence, and we know from the denser medium to rarer medium, if the light ray wants to propagate, then it will bend away from the normal. And in this picture, we can easily observe that the angle of incidence I is genuinely less than the angle of refraction, as the light ray has propagated from optically denser medium to optically rarer medium. From the second example, we have realized that the angle of incidence will be less than that of the angle of refraction while the light ray is propagating from optically denser to optically rarer. Now, if the angle of incidence increases, then the angle of refraction will also be increased. At a certain angle of incidence, if the angle of refraction becomes 90 degree, or the light ray passes through the interface after refraction, then the angle of incidence is going to be termed as critical angle, and it is a very important phenomena of light ray. As an example, for water and air boundary, the critical angle is approximately 48 degree.
Now we are trying to implement a relation between the refractive index and the critical angle. We know we will only get the critical angle if the light ray starts propagating from optically denser to optically rarer medium. And here we go. So now this is the interface. This is optical denser medium and this is optical rarer one. The light ray is propagating from denser to rarer medium, and B is the point of incidence. We are trying to construct a normal at B. So we have constructed a normal and we are naming it as n dashed. So n dashed is the normal on interface. Now let us imagine that this is water and this is air, and this is the angle is the critical angle. So the light ray which incidents at critical angle from denser to rarer medium will propagate through the interface. So it will propagate through the interface, that is the angle of refraction or R will be 90 degree. As we have denoted the denser medium as water and rarer medium is air, so imagine denser medium is water and rarer medium is air. Then the refractive index of air with respect to water, because the light ray is propagating from water to air, that's why we have written that the refractive index of air with respect to water, that is W mu A, that will be written as sin IC by sin R. But angle of refraction here is 90 degree. So we can write W mu A, that is sin IC by sin 90 degree. So we know sin 90 degree equal to 1. So basically W mu A equal to sin IC. But we know
that W mu A is nothing but 1 by A mu W.
That is the refractive index of water with respect to air. Clear? And this is the relationship between the refractive index and the critical angle.
We have come to know that during the refraction from optically denser medium to optically rarer medium, if the light ray incidents at an angle of critical angle, then the light ray will pass through the interface. But if the angle of incidence becomes more than the critical angle, then the light ray will be unable to come out from that medium. In this phenomenon of monochromatic light ray, the total light ray will be reflected back in the same optically denser medium, and this is known as the total internal reflection. In the total internal reflection, there is no possibilities of absorptions of light ray. As a result, 100% of light ray is going to be reflected back in the same denser medium, and the total internal reflection takes place when the light ray travels from optically denser medium to optically rarer medium, and the light ray needs to be incident on the interface more than the critical angle. If we try to differentiate between reflection and total internal reflection, then we will find that a smooth surface is required for reflection, but for total internal reflection, no smooth polished surface is required. In reflection, the absorptions of light ray occurs, but in total internal reflection, there is no absorption of light ray occurs. Reflection can be occurred at any angle of incidence, but the total internal reflection occurs only when if the light ray propagates from optically denser to optically rarer medium and incidents at interface more than the critical angle. We will discuss something about prism. A prism looks like this. An optical prism has total 5 surfaces. 2 of them are triangular and 3 of them are rectangular. An optical prism is a piece of glass or any other transparent material bounded by 2 triangular and 3 rectangular surfaces. A prism is basically an optical element, flat, polished surfaces that refract the light. And the angle between two refracting surfaces of a prism is known as the angle of prism. In the next diagram, we will able to see what is the angle of prism and what are the refracting surfaces. There are two refracting surfaces which are holding the angle of prism, and as a result the angle of prism is known as the refracting angle of prism. As we have told earlier that a prism is a refracting surface which refracts the light. Now we will try to realize the deviation of a light ray with the help of a prism. Basically, we will go through the refraction through a prism. Consider a light ray EF. It tries to propagate through a straight path. So, if there is no transparent medium in between EF, then it will propagate up to G. But we have placed a prism where the light ray has the point of incidence at F. As the prism is made by glass or any other transparent material, so it is optically denser than that of air. The light ray which is propagating through EF and the point of incidence F, if we construct a normal at the point of incidence, then the light ray will propagate towards the normal as it is implementing from rarer to denser one. So we have constructed a normal NO at the point of incidence, and we have observed that the light ray is refracted through FH, and that is nothing but the refracted ray. At AC surface, the refracted light ray has the point of incidence at H. Now, we have told earlier that the prism is the optically denser one. We have constructed a normal on AC surface, that is MO, and it is obvious that light ray will propagate away from normal as it is propagating from optically denser to optically rarer medium. So ultimately the light ray will propagate through HI pathway, and this is known as the emergent ray. From the previous discussion, we can easily conclude that we have observed two different types of refraction. In the first case, at AV surface, the light ray has propagated from optically rarer to optically denser medium. That is, the light ray is propagating towards the normal. But in the next case, we have observed at AC surface that light ray is moving away from the normal as it is moving from prism to air. So we can easily conclude that the light ray intends to go through EG pathway, but ultimately it has moved through HI pathway, and if we extend HI in backward direction, it touches EG at K. So the angle made by GKI is nothing but the angle of deviation. The angle of deviation is nothing but the angle equals to the difference between the angle of incidence and the angle of refraction while the light ray is passing through different transparent mediums.
From the previous discussions, we have come to know that the angle of deviation is going to be defined by angle GKI, and that is going to be defined by del. So now we will try to find out the equation on GKI, that is the angle of deviation. Let the angle of incidence equal to angle NFE, that is I1. So basically this is the angle of incidence, as because we know EF is nothing but the incident ray. Now in the first surface, so at AB surface, the normal equal to N0. So we can easily write that N0 is nothing but the perpendicular over AB. So on AB surface, angle of refraction equal to angle. So this is my angle of refraction. So this is going to be defined by angle HFO, that is R1, and it is very obvious that the light ray has moved from rarer to denser medium. That's why the angle of incidence will be greater than the angle of refraction. Now we can say from the first surface the angle of deviation will be nothing but this particular angle. So at AB surface the angle of deviation equal to angle KFH, that is nothing but I1 minus R1. Now the light ray has propagated through the FH path, and that is nothing but the refracted ray, and ultimately from AC surface it has incidented at an angle of R2. So let the angle of incidence at AC surface equal to angle FHO, that is nothing but R2. But we have told you earlier that the total angle of deviation must be GKI. But from the triangle KFH, we have come to know that the angle GKI is the exterior angle. So this will be the sum of two furthermost interior angles. So from the triangle KFH, we can write that angle KFH plus angle KHF is nothing but the GKI. So implementing the value of KFH and the value of KHF, we can write the total angle of deviation, that is GKI is nothing but I1 minus R1 plus I2 minus R2. So we can write I1 plus I2 minus R1 minus R2, that is nothing but del. So we can simplify it in such way, and this is nothing but the angle of deviation. We are trying to simplify the equation of the angle of deviation. We know the sum of three angles of a triangle must be 180 degree. So from the triangle of FHO, we can write the sum of three angles, that is angle FOH plus angle OHF plus angle HFO must have the value of 180 degree. But we are implementing FOH as that OHF is going to be written as R2 and HFO is going to be written as R1, that is 180 degree. So this is the equation 1. Now we are going to consider the quadrilateral, that is AFOH. And we know the sum of four angles of a quadrilateral must be 360 degree. So we can write angle AFO plus angle FOH plus angle OHA plus angle HAF must be 360 degree. Now AFO is going to be written as 90 degree because NO is the normal constructed on AB surface. So all the angles or interface over the normal must be 90 degree. So we can easily write that angle AFO equal to 90 degree. In the same way, the next FOH is going to be written as it is. But angle OHA is going to be written as 90 degree again, because angle OHA equal to 90 degree as because MO is perpendicular over AC, and angle HAF, that is nothing but the angle of prism, that is going to be written as A. So now simplifying the value, that is FOH plus A, that will be equal with 360 degree minus 180 degree. So angle FOH plus A, that will be 180 degree, and this is going to be termed by equation 2. Comparing both the equations 1 and 2, as both of them has the value of 180 degree, we can write that angle FOH plus R1 plus R2 equal to angle FOH plus A. from both sides FOH is going to be cancelled out. So A equal to R1 plus R2. But we have established that angle of deviation del equal to I1 plus I2 minus R1 plus R2. That can be written as I1 plus I2 minus A. And this is the ultimate equation of angle of deviation. Now we are trying to plot a graph between the angle of incidence and angle of deviation. So if we plot the graph, we will get a graph like this, where the right side is bit tilted and in this point the angle of deviation will be minimum. So here angle of deviation will be minimum. And we can prove mathematically for this angle of incidence I1 must be equal with I2. And end of the session. Stay home, stay safe.